Good morning, students. I am Nipun Ahuja, Assistant Professor MAE, HMI Institute of Technology and Management. I am taking your another class on Engineering Mechanics, Unit 3. The topics which I will cover today, the loss of energy in collision, and I will do two numericals also on collision. We have discussed in last presentation different types of collisions and uh, different cases of collision. Now we will go ahead and we will discuss loss of energy in collision and numericals on collision. Let's go ahead. Let us first of all discuss loss of an energy in collision. Now let us suppose there are two masses Ma and Mb having velocities Va and Vb. They collide with each other and having the central direct impact, right? We have already talked that what is central direct impact. Central direct impact is basically when the line of impact passes through the center of the two masses, as well as the velocities Va and Vb are also aligned with the line of impact. Then it is known as central direct impact. So we are having actually two masses Ma and Mb having velocity Va and Vb colliding with central direct impact, right? And the velocities after the impact, let it be Va dash and Vb dash. Now let us suppose that the kinetic energy of two masses before impact will be 1 by 2 MAVA square plus 1 by 2 MBVB square, and the kinetic energy of the two masses after impact will be equal to 1 by 2 MAVA dash square plus 1 by 2 MBVB dash square. So what would be the loss of kinetic energy during the impact? It would be kinetic energy of two masses after impact, sorry, before impact, kinetic energy of the two masses before impact minus kinetic energy of the two masses after impact. That is 1 by 2 MAVA square plus MBVB square bracket closed minus MAVA dash square plus MBVB dash square. So this would be the loss of kinetic energy. But let us suppose we do not know VA dash VB dash and we want kinetic energy formula in variables MA, MB, VA, VB. So how to do that? So let's do some derivation related to this. Let's go ahead. As we know that the conservation of momentum is MAVA plus MBVB equal to MAVA dash plus MBVB dash. Let this be one equation, and another equation is coefficient of restitution we know equal to minus of VB dash minus VA dash upon VB minus VA. So VB dash minus VA dash will become minus E into VB minus VA. So let the first equation conservation of momentum be 18.11 and the coefficient of restitution equation is 18.12. Now since we want to express the loss of kinetic energy in terms of two masses of bodies as well as the velocities before impact, so we have to eliminate Va dash and Vb dash. So how to do that? Let us do one thing, that the equation 18.10, this last equation, uh, what multiply with MA plus MB and divide it with MA plus MB. So when we multiply this equation with MA plus MB, we get this thing: MA square plus VA square plus MA MB VB square plus MA MB VA square plus MB square VB square minus MA square VA dash square minus MB MA VB dash square minus MA MB VA dash square minus MB square VB dash square. So if we solve again, we get 1 by 2 MA plus MB, and we get formula MA VA plus MB VB whole square plus MA MB VA minus VB square minus MA VA dash plus MB VB dash square plus MA MB VA dash minus VB dash square. So now if we see this equation 18.11, and if we square this equation, we can put uh, put for this thing, right? So this thing and this thing would get eliminated when we put the square of this equation in this equation. So we get then we get the equation loss of kinetic energy equal to 1 by 2 into Ma plus Mb in bracket Ma Mb Va minus Vb square minus Ma Mb VA dash minus VB dash square. So now our equation is now little less complicated. So now we have to eliminate this VA dash minus VB dash. So if we again see this equation and if we square this equation and put for this VB dash minus VA dash that E into VB minus VA whole square. So we will get loss of kinetic energy equal to 1 by 2 MA plus MB in bracket MA MB VA minus VB square minus MA MB E square into VA minus VB square, right? So when we further solve, we get MA MB upon 2 MA plus MB in bracket VA minus VB square into 1 minus E square. So finally, we get loss of kinetic energy, that is MA MB upon 2A MA plus MB in bracket VA minus VB square into 1 minus E square. So this is the formula for loss of kinetic energy dependent upon masses MA MB and initial velocity VA VB and coefficient of restitution. So remember this formula. This formula is very important for further numerical, and this derivation is also very important for your exam. So do understand this equation, this derivation, and remember this formula, right? So let's go ahead. Let we do two numericals uh, on collision. Let us suppose this is a numerical. In this numerical, there are three spherical balls having mass 2 kg, 6 kg, and 12 kg. They are moving in same directions, having velocities 12 meter per second. The 2 kg mass having velocity 12 meter per second. 6 kg mass has 4 meter per second velocity. 12 kg mass has 2 meter per second velocity. All are moving in the same direction. If the ball of mass 2 kg impinges this ball 6 kg and further this after this impingement this mass 6 kg impinges 12 kg mass, we have to prove that after this impinging uh, these two masses get stopped, they come to rest. So this we have to prove, that is VA dash equal to 0 and VB dash equal to 0. This we have to prove, and we are assuming that the balls should be perfectly elastic. So if the balls are perfectly elastic, we know coefficient of restitution is equal to 1. So let us try to solve this numerical. For perfectly elastic ball, E equal to 1, MA we know 2 kg, MP we know 6 kg, MC equal to 12 kg. Now first of all, we will discuss impact of these two balls, this ball and this ball. So we know conservation of momentum, which is known as MA, the formula which is MAVA plus MBVB equal to MAVA dash plus MBVB dash. So mass we know 2, initial velocity we know, mass MB we know, initial velocity of B ball we know, again MA and B we know. So we get formula in terms of VA and VB dash, VA dash and VB dash, it is 2 VA dash plus 6 VB dash equal to 48, right? And again we know coefficient of restitution is equal to minus of VB dash minus VA dash upon VB minus VA. So VB dash minus VA dash will be equal to E into VB minus VA, right? And this is VB dash minus VA, not VB dash equal to VA dash. This is wrongly printed. This is VB dash minus VA dash. So we put for E equal to 1, VB equal to 4, and VA equal to 12. So we get VB dash minus VA dash equal to 8. So we get two equations of variables VA dash VB dash, first equation and second equation. When we solve both the equation, we get VA dash equal to 0 and VB dash equal to 8 meter per second. So uh, this first ball gets to the position of rest. So the first proof is there that VA dash is equal to 0. Now we discuss impact of ball B and C, this ball and this ball. Now the initial velocity is this 8 meter per second, not of this ball. So this with this velocity it impacts this mass 2 meter per second, right? So again we apply conservation of momentum MBVB plus MCVC equal to MBVB dash plus MCVC dash. So again putting formula for MB and MC, that is 6 and 12, and VB and VC, that is 8 and VC 2. Here the VB is 8 because this VB dash is, we found at 8 meter per second. So and again we put for MB so we get formula BB dash plus 2 VC dash equal to 12, right? This is first equation. Another equation we can find through coefficient of restitution, which is E equal to minus of VC dash minus VB dash upon VC minus VB. So the formula will be VC dash minus VB dash equal to E into VC minus VB, which is equal to E minus 1 into 2 minus 8. So we get VC dash minus VB dash equal to 6. So we get two equations, this equation and this equation. Solving them, we get VB dash equal to 0 and VC dash equal to 6 meter per second. That is VB dash again it comes to rest, and VC dash, that the ball C start moving with 6 meter per second. So finally we get that when ball A impinges ball B, this ball comes to rest, and this ball start moving with 8 meter per second. So this is first proof. And when this ball B impinges ball C, then ball B comes to rest and ball C start moving with velocity 6 meter per second. So actually uh, we had to prove this, that a ball of mass 2 kg and 6 kg will be brought to rest by the impact. So this we have proved. So first question is finished. I hope you have understood this question. If you have any query, we can talk regarding this in our online meeting. Either we will be having on Zoom or Microsoft Teams, right? So let's do another question. In this question, there is a glass ball which is dropped on a smooth horizontal floor from which it bounces to a height of 9 meter. On the second bounce, it rises to a height of 6 meter. From what height the ball was dropped, and what is the coefficient of restitution between the glass and the floor? So let's see this question diagrammatically in diagram. There is a ball, right? This ball drops from height h to the floor, which is having mass, let us suppose infinite, and the initial velocity and final velocity of this floor is equal to 0. So, so when this ball impinges this floor, that the velocity will be would be v, and 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 again this ball uh, goes back to the height 9 meter with the velocity v dash, right? And then again it comes back to the floor, and in second impact the velocity would be v double dash, and it again reaches to the height 6 meter, that h double dash, which is equal to 6 meter. Now we actually have to find this h and the coefficient of restitution, that is small e, right? What we know, h dash and h double dash 6 meter. We do not know v, we do not know v dash, we do not know v double dash. So if we find h in terms of h dash or h double dash, and if we find e also in terms of h dash and h double dash, we can solve this numerical. So now let's start solving this numerical. Now when the ball drops from a height h, we know the relation to v square minus u square equal to 2s. Initial velocity of the ball is 0. So and the height of the ball is h. So when the ball strikes the floor, and at the time of hitting, the velocity would be equal to root 2 gh, because u equal to 0 and s equal to h. Now let the v dash be the velocity of the ball in the upward direction after the first impact, right? And as it is given the second body, that is floor, that it is having very large mass and it is at rest. So we get coefficient of restitution for the first impact equal to minus v dash minus 0 upon v minus 0, where v dash is the velocity of the ball after impact, right? And 0 is the velocity, final velocity of the floor after impact, and v minus 0 is the initial velocity of the ball, and 0 is the initial velocity of the floor. So we get v dash equal to minus e into root 2 gh. So we get actually v dash in terms of h and e. So now now here we are getting v dash when it is in downward direction, but actually ball is moving in upward direction. So v dash is actually equal to e into root 2 gh. Now this ball will rise up to height 9 meter, right? And we know that uh, we know again this formula b square minus u square equal to 2as. Now u is 0, right? And s is h dash. So b dash will become root 2 gh. So when we put this in here, we get minus e, sorry, here minus e root 2 gh equal to root of 2 gh dash. So when we solve this, we get h dash equal to e square h. So we get h dash in terms of e and h, right? Now let's discuss second impact, right? In second impact, we have final velocity v double dash, initial velocity v dash, and the height is 6 meter, right? So when we use the coefficient of restitution formula, e equal to minus v double dash minus 0 upon v dash minus 0, where 0 is the initial velocity of the floor, here is the final velocity of the floor and the initial velocity of the floor. So we get v double dash equal to minus e into v dash, right? So, so here when we uh, when we use the uh, uh, when we use the formula v double dash equal to root 2 g h double dash, right? So we basically get root 2 g h double dash equal to minus ev dash, right? Uh, because v double dash we know ev dash, so we get root 2 g double dash equal to minus ev dash, and v dash actually we have already found here, that is root 2 gh dash. So we put here, so we get root 2 gh double dash equal to minus e into root t gh dash, and we get h double dash equal to e square h dash. So we actually get e square equal to h double dash upon h dash. H double dash and h dash we know, h double dash 6 meter, h dash 9 meter, right? So we get 6 by 9 and e square equal to 2 by 3, and finally we get e equal to 0.816, and thus h dash equal to e square, so we get actually e equal to 0.816, and again when we use this formula, just a minute, this formula h dash equal to e square h. So when we put for h dash and value of e which we have found here, we get h equal to 13.5 meter. So finally we have calculated e equal to 0.816 and h equal to 13.5 meter. So these are the answers. So I have discussed two numericals on collision. These numericals are also available in uh, Taneja and a style book of engineering mechanics. Right, you can see it there also. I will share this presentation with you also. So this is at the end of unit 3. The last two presentation I have discussed on on the YouTube, this presentation and the last presentation. So we will have a two doubt session, in two different online classes, maybe tomorrow and day after tomorrow, right? Then I will give you assignment on unit 3 that you have to complete and send me in next 4 days. I will tell you the date also, and after this we will discuss, we will start unit 4, and then we will do assignment on unit 4, and if we still get time, we will do more numericals on unit 3 and unit 4. So I hope this presentation you have liked, and uh, and we will I will look, I look after to have more presentations with you and more online classes. Thank you. Thanks a lot.